In this video presentation, we're going to discuss how clip fan generator based wind energy can be used in household and lighting setting. So first, we're going to present the development and progress of the prototype. So in this video, we placed the 19 inches length and 18.5 inches plywood for the base of the prototype so that it can be the support for the entire prototype when it is ready for the testing. And we placed the 12.5 inches PVC for attaching the clip fan dynamo up to the thread where the dynamo electrical generator been placed. Then we also installed the 19 inches PVC pipe to become the body of the tower. For the blades, it measures the 13 inches and it is estimated shape will be the best to catch the wind and spin efficiently. Initially, we connect the blades to the dynamo with the use of appropriate tools and equipment. Then, we proceed to connect the wire that are suitable for outdoor use. And we also connect those wires to the charger. It is to regulate the flow of electricity generated by the wind turbine. It is to ensure that it's safe and efficient charging of batteries. Then, this battery will be the storage of the current collected by the turbine. And the stored energy from the battery will proceed to the inverter that is very essential for converting the DC current to AC for electronics devices. Then the next one is the test and evaluation. To test the functionality and performance of the wind turbine prototype, there was a comprehensive set of procedures must be followed. These procedures typically encompass mechanical, electrical, and aerodynamic assessment to ensure that the turbine operates efficiently under various conditions. The first step is the preparation and setup, where its objective is to verify that a wind turbine design meets all of specifications and safety standards. Then the next step, we choose an appropriate testing site where it is located below the top of the roof of the house, where it is reliable in wind conditions. Regarding to the data we're going to measure and analyze, the prototype shall undergo some methods to analyze its capability in terms of wind speed, direction, and power output within voltage, current, and power. In general, a small wind turbine can consume a normal wind speed of 5 ms to generate electric current with an estimated power output of 12 volts and 4 amp hours. This means that the voltage determines the electrical pressure, while the amp hours determine how long the battery can sustain the pressure before needing a recharge. Then we will now proceed to the physics principles. The process of the designing a wind turbine involves the conceptual implementation of a number of electrical and mechanical subsystems to create a machine capable of converting the energy contained in wind to useful electrical energy. The developing of the wind turbine uses the physics of aerodynamics and electromagnetism to convert energy to electricity. Aerodynamics is the study of how air interacts with moving objects. In this project, aerodynamics applied the designing of turbine blades, where the airflow shaft of the blades create a pressure difference between the top and bottom of the surface. The shape and angle of the clip of fan blades influence how effectively they capture wind energy. blade should be designed to create a low pressure zone on their front surface and to high pressure zone on their rear surface, causing the airflow to smoothly around the blades and generating lift. Regarding to the aerodynamics, it composed of two fundamental concepts that can be called as lift force and drag force. So let us discuss what are the lift force. Lift force is the upward force exerted on the turbine blades as a wind flows over them. It's similar to the lift force that allow airplanes to fly. As wind flows over the curved surface of the blade, it creates a pressure difference between the upper and lower surfaces, generating an upward force perpendicular to the blade. This force causes the blades to rotate, which ultimately drives the turbine's generator to produce electricity. So let's now proceed to the drag force. Drag force is primarily caused by the friction between the air and the turbine blades and tower. The shape and surface texture of these components influence the amount of drag. Turbulence. The airflow also contributes to drag.